Today's video will be setting up the defaults when SIZER is started. So once SIZER is installed and you've got this window open, to get to the defaults we're going to go to Options. Once this pop-up shows up, we will go to Supply System Pre-Assignment, and the first setting that we want to make sure is correct is this Select Standard Supply. So we want it to be selected as 480 volts, 3-phase AC at 60 hertz. So you've got all these options, but we want to make sure it's defaulted to that before we start SIZER, start a project. The next settings that we're going to look at are dimensioning default settings. So when we click on this tab, the two settings that we're going to look at are current check and thermal utilization down here. So first, current check, we want this box checked so that way for simple motor selection it's dimensioned with the stall current. We want to make sure that box is checked. And then for thermal utilization, I think it'll start off at 100%, but we want to set it to 90%. Once those settings are changed, we're going to hit OK. And you've just set up the defaults for SIZER. We will be configuring a motor with a specific part number based on a previous configuration. So we're going to open SIZER and go to project name. I'm going to go ahead and name it SIZER Tutorial. Hit OK. And I'm going to create project. And I do want to replace the existing project. So first it has a getting started, so it'll have some pointers and bullets on these tabs that are located up to the top left that are mechanical systems, drive systems, open loop control, closed loop control, 24 volt, and cabinet modules, as well as additional components. Notice that these are all green. I know for this one we will do drive systems, so we'll double click new drive system. And for this one we will do a multi-axis converter, smart line module, and for the x-axis we're doing a 1FT, 1FK servo motor. As you can see on the right, it says servo motor, and the black and yellow border is around a drop-down menu of safety integrated functions. So you can have different options. We're going to go ahead and do the no drive based safety integrated functionality. And then we're going to come down here to load type and select simple motor selection and hit OK. Notice that after doing so, Properties has a green check mark, so that is complete. But also these tabs, the drive systems, and these control modules both turned white. So you have to complete several of these other options that have opened to complete these full systems. But for this motor, there's the ambient conditions, which have default settings. We're going to leave them as is, and we're going to come to motor. Then for this one, I know that we're not going to want a mounted gearbox, so we're going to come down here to Next, click on that. And for the basic type specifications, we're going to do it based on a complete order designation. And we can get this part number from the catalog as seen here. After finding the part number that you want, simply type it in. I'm going to do 1FK7062-2AC71-1RG0, and then hit next. And the motor that we selected from the catalog is now picked out, so we can click on it and hit next. And then it opens us to a characteristic torque curves that are rated at a specific operating point. Now you can click this box right here with the move operating point, and you can move it along the S1 curve and change it that way. And this load data changes as you move the operating point. But we're going to leave it as is and hit next. And then you can choose the encoder and the shaft extension. We're just going to leave that like that and hit finish. Now motor has a green check mark. So now we'll go to motor module. Again, the ambient conditions are already defaulted, and we will go to motor module. You notice that there's one highlighted, and SIZER selects one that it believes is the best fit, and it displays the ones that are only allowable for this motor. And for this exercise, I know to select the double motor module book size D type, and then click on that and hit OK. And now motor modules checked. So now I'll go to output components. There will be no output options. And for the power cable, I know I want to do the 800 plus without break cable with the quick connector. And the 800 means the cable is flexible. And I know the length is going to be 13 meters. There will be no external fan, no extensions, so I can go ahead and scroll down and hit OK. And for the encoder evaluation, you have the motor encoder, but we won't need a first external encoder for this exercise, and hit OK. So now we have, you can see the output components, motor module and motor, both have a green check, as well as the axis. So we can right click the axis and hit rename and name it X axis. And you have just completed the X axis with a specific motor part number. For this video, we will do the Y axis with the exact same motor as the previous video used for the X axis, but we will get that motor based on some specifications without knowing the part number. So I'm going to open up the project that I created, which was the SIZER tutorial, so I'm going to double click that. And it opens up to the page where we finished the X-axis configuration, which was done last video. To create a new axis, come up here to the blue and click New Axis. And we're going to do the same 1FT, 1FK servo motor, no drive based safety integrated functionality, and we're going to do the simple motor selection and click OK. So we still have the ambient conditions, which they are defaulted, and we're going to leave as is. So I'm going to click on motor. I know I don't want a mounted gearbox for this axis or this motor, so I'm going to go ahead and click next, and it brings us to the basic type specifications. In the last video, we clicked on complete order designation and filled out the part number, which was found in the catalog, which is shown here. However, for this axis, we're going to do the basic type specifications. So the motor encoder is going to be a multi-turn. The cooling method is self-cooling, and the holding brake we're not going to have because it is the Y-axis for this example. And we're going to hit next. And it brings us to this table with specifications for each motor, such as rated torque, rated current, max torque, and you can see all the motors on the left-hand side. So I'm going to sort it because I know we want the 1FK 7062-2AC71, which was used in the X-axis. And so I'm going to click that and click next. So then it brings us to the characteristic torque curves, and it shows the load data up here, and you can move the operating point as needed by checking this box. So I know we want to leave it as is, so I'm going to hit next. And as you can see, there's the order designation up here, but as in video 2, I want the 20-bit absolute encoder, and now you can see that this order designation is now exactly the same as the motor chosen in the second video for the x-axis. And so I'm going to go ahead and hit finish, and now onto the motor module. So again, ambient conditions are defaulted. Now we're on the motor module, and the motor modules can be seen in the catalog here. But for this example, we see that SIZER thinks this is the best motor module size or selection. However, I know we want to do the double motor module book size D type for this axis, and I'm going to hit OK. And now the motor module is done. So finally we want the output components. So there are no output options, and now we're on the power cable. So like on the x-axis, we're going to do the 800 plus without break cable quick connector, and the 800 is the flexible cable. And for the cable length, we're going to do 13 meters again. And there's no extensions, and the external fan is not necessary for this example. And for the encoder evaluation, we have the motor encoder, which was chosen previously. However, we do not need a first external encoder in this example. So I'm going to go ahead and click OK. And now you can see that the y-axis is complete. So we can come to the left-hand side and right-click axis and hit rename and just type y-axis. And there you just finished the y-axis, and you've gotten the same motor configuration as done in the x-axis. However, it was done in a different way. And for this video, we will be going over the z-axis with the same exact motor. However, we're going to do it with a mechanical system. So I'm going to open up my project, which is the SIZER tutorial, so I'll double click on it. And it brings us back to this page. Again, to make a new axis, just click on new axis up here in the blue. I know the motor, as mentioned before, is going to be the 1FT 1FK servo motor with no drive base safety integrated. And instead of going with the simple motor selection and load type, we're going to go with the mechanical system. And it brings down a drop down menu on the right hand side. So the mechanical system we're going to select is a ball screw. And then we'll click OK. And so here are the ambient conditions. They're defaulted. We're not going to mess with them. But the mechanical system has some values that we need to play with. So based on the preset configuration, I know that the internal mass of the spindle is 400 kilograms. And then coming down here to moments of inertia, the spindle diameter is 25 millimeters. And the spindle length is 1.5 meters. So the spindle density, we're going to go with the steel. So once I selected the material, you notice that the spindle moment of inertia is calculated for you. So we didn't have to calculate it, it automatically calculates it based on the moments of inertia that you input. So now we can go to the mechanics. And so with the lead screw pitch, we're going to do 10 millimeters. And angle of inclination is going to be 90 degrees because it is the z-axis. And so now we're on to the friction. The thing that we have to input is the specific coefficient of friction. And for this one is going to be 10 thou. And that will be the information that we have to put in here. But before we move on the left side it shows an example of a ball screw mechanical system. So the information we input on the right leads to the ball screw that we're going to use for this example. So now we're going to go ahead and click next. to fill out some more sections. So for section 1, I know we want the trapezoidal, but we want the ST speed and time for acceleration and velocity. So we're going to go with that. We're going to do forward, and we're going to also have to do a backward. So we're going to go ahead and do that. And we'll do backward and down. So the traversing distance I know is going to be 0.66. The travel time is going to be 3 seconds. And it fills out the attained values right here. So with those numbers, it fills out the corresponding data, and it outputs this velocity curve and acceleration curve. So you can see that data there. And now we can hit finish. So now, once that's finished, the mechanical system is complete. So now we can go to motor. And so I know, again, for this motor, we're not going to have a mounted gearbox, so I'm going to go ahead and click next. And so it brings up the characteristic torque curves and the load speed curve. So as you can see, it'll show this graph, and it shows the duration and some data up at the top. So I know, as you can see the graph, this is what we want for this specific configuration that was already predefined. So I'm going to hit next. So then it brings us to this page. For this one, as my default, it's the thermal utilization is 90%. So I am going to go ahead and hit next. And so then it brings us to a familiar page of the basic type specifications. So I know it's a multi-turn, and the cooling will be self-cooling, but since it's the Z-axis, I want a holding brake. So we do with holding brake, and we're going to hit next. So then it brings us to this table that we saw before of the specifications for each motor. I know that I want it to be 1FK, and we're going to do the 7062 2AC 71 like in the previous 2 axes. But since this is a mechanical system, we're going to do it this way. And we're going to hit next. And then it brings us to the characteristic torque curve that we are used to, not the load speed curve. So we have this load data, and we've got the thermal utilization, which we have is 83%, which is good, and we've got the data that can be obtained right here, you can see. And that is the operating point within the specs that we gave of the ball screw. We're going to go ahead and hit next. And so now we can see the order designation up here. And now the only thing we have to change is the motor encoder is going to be the 20-bit absolute encoder. Now you can see that the order number is slightly different at the end. It's not an RG0, it's an RH0. But that is because it has a holding brake this time as opposed to not having a holding brake. And then I'm going to hit finish. So now we're onto the motor module. So for the motor module, we have the ambient conditions, which we're not going to change, and so we're going to go to motor module. So for this time, I know for this axis we don't want a double motor module. So when we look at what SIZER selects, it selects or recommends a single book size. However, I know for this axis we're going to go with the single book size D type. We're going to go ahead and hit OK. So now finally we're on to the output components. So There are no output options, and now we're on the power cable. Again, we want the Motion Connect 800 Plus with brake cable quick connect. Flexible cable is the 800, and for the length we're going to do again 13 meters for this example. We're going to have no extensions, and an external fan is not necessary. And we're on the encoder evaluation. So we've got the motor encoder, and we do not need a first external encoder for this example. So we're going to hit OK. So now we just completed the Z-axis with a mechanical system configuration. So we can come to the left and rename it Z-axis. And there we just completed the Z-axis. So we've completed so far the X, Y, and Z axis, which all have the same exact servo motors, and they were all obtained a different way. One was through a preset catalog part number that we found in the catalog. The Y axis was through some basic specifications, and now we just did the Z axis, which was done through a mechanical system that we used, which was a ball screw. And today we will be configuring a spindle motor through load characteristic load type. So let's get started. Once you have SIZER open, you can open your project. So mine was SIZER tutorial, so I'm going to double click on that, and it'll open us to a familiar page. So again, to start a new axis or new set for a motor, you click new axis, and everything will be the same, multi-axis SmartLine module, but this time we will do the 1PH8 servo motor, and no drive-based safety integrated, but we're going to go ahead with the load characteristic type and hit OK. So again, there's the ambient conditions. They're defaulted. We're going to leave them as is, and we're going to hit motor and start going with the load data. So the load behavior, I know we want constant power of 10 kilowatts, and for the corner speed we want 1500 RPM, and at the max load speed I know we want 4500 RPM. Hit enter, and it brings the curve up, the torque curve with the base load. So I'm going to hit next, and now we're on the basic type specifications. So this motor principle, I know I want asynchronous, forced ventilation, and no brake. So we can continue. And so it brings us back to the table of motor specifications, rated torques, and so on. So I'm going to go ahead and sort in ascending order, as well as I want to sort according to frame size. So SIZER gives a thumbs up on what the good motor would be based on frame size and what was previously done. So I'm going to select this one and hit next. And it brings back us to the characteristic torque curves and some of the load data. It gives the load current right here. I know we don't want to change anything, so, and you can kind of drag your cursor along and you can see the data change in this pop-up menu as you drag your cursor across. So I'm going to go ahead and hit next. And so here's the order designation. So for this example, I know we want the incremental encoder, 22-bit. It's motor integrated. I want no mounting preparation, but I do want the airflow direction from drive-in to non-drive-in. We're going to keep everything else the same. And so I'm going to hit finish. And so that is the motor configuration done. So now I will go to the motor module, and you can see that the ambient conditions are defaulted, but I'm going to go ahead and go straight to the motor module and click next. And so you can see that SIZER selects this book size, but I know for this one I want the single book size C type for this example. Based on the preset configuration, I know this is the motor module that we want. So I'm going to go ahead and click OK. And so the motor module is now finished. You can see the check mark, and now we're finally onto the output components for the spindle. There are no output options, so I'm going to go ahead and hit OK. And we're going to open the power cable. So, as the other ones, I want the 800 plus without break cable and the full thread. And so also I want to keep this cable at 10 meters. Whereas in the others I wanted 13 meters. I'm going to keep it at 10. So now I'm clicking on to scroll down, and I don't want an external fan. That's just not necessary for what we're doing in this example. So I'm going to hit OK. And so now you can see that that is complete, and we're on to the encoder evaluation. So click on the encoder evaluation to see that the motor encoder is there. But for the spindle, we want a first external encoder. So we're going to go ahead and click encoder evaluation only. And we want an encoder for evaluation with SMC 20. Okay. So now we want to go to the cable type. So I want the Motion Connect 800 IP20 IP67 for sine and cosine trail type. So I'm going to select that one. The length I'm going to keep as 10 meters, and I don't want an extension. That's not necessary. So for the single connectors, I want 0 mounting flange and 0 high frequency clamp. So then I'm going to scroll down, and you can see that I don't want a second external encoder, so I'm going to go ahead and hit OK. So that is complete with the power cable and encoder evaluation. And now you can see on the left hand side that the motor module and output components have been configured with the green check. So I can come here and rename it the spindle. Hit enter, and it renames the folder, and we just completed the spindle configuration using load characteristic load type. And today we will be finishing up with the drive systems by configuring the line module and system components. So to get started, I'm going to open up SIZER, which is open, and now I'm going to click on my project, which was SIZER tutorial. And it brings us up to this very familiar screen, and going to the left, you can see on the top left that the drive system still has a white box. So by the end of this video, we will have it green, which means it's complete. And going down, you have system components and line module still white. So we are going to fix that by configuring them. So to start off, we're going to go to line module. And I know I have 2 double motor modules for the X and Y axis. So I am going to assign automatically and hit OK. So for the DC link power, there's 2 ways to do it. The first way is I know for this application that the coincidence factor it chose is correct. So the coincidence factor is for when the axes work simultaneously, so or with each other. So what it does is I know we won't be using the max torque and max speed when using both axes, like several axes at the same time. So it uses the coincidence factor to determine the power that goes to the motor at when they're working together. So this will decrease your DC link power, so that way you don't have to have as big of a power module. Now, the second way is back in the motor configurations, there is the N and N rated. So if you adjust that number, it will adjust this coincidence factor near the end. And this will allow you, if you know that all the information such as your spindle and the coincidence factor and the power that your motors will use together, you can adjust this coincidence factor and modify it right here. However, in this application, I know we're going to keep it the same, but just know that you can change it based on your application and your machine tool system on the power that is needed for your motors and your application. So I'm going to go ahead and hit OK, and the desealing power is now complete. So now there's the line module. So back in this screen you can see that this one's highlighted, and that is what SIZER recommends. I'm going to select for this application the one that SIZER recommends, and I'm not going to adjust any of these options up here. I'm just going to select what SIZER recommends and then hit OK. And for the braking components, I'm not going to mess with any of this. I know for this application we're just going to hit OK, so there's no braking components. And now you can see that line module is now checked off, and on the left hand side it is also checked off. So finally we're on the system components. So pretty straightforward here. We've got the input options. I'm not going to select any of this. I just have the line choke, which is blanked out, but it is also selected based on previous selections, and I'm going to hit OK. And additional accessories, you can add this additional warning notice, but I'm not going to select that, and I'm going to hit OK. So now that system components is complete. You see a green check on the left, you see system components is a green check, and now on drive systems on the top left it has a green box. So that means the drive systems is now complete. So now the next thing to do is configure the actual controller, and that will be in future videos. Thank you for staying tuned. That was video 6, configuring the line module and system components.